We've been building a lot of code as we've been starting to think about how to deal with Python. And this is great. And it would be fantastic if our code always worked perfectly the first time we ran it. Of course, it'd always be nice if I won the lottery every time or my favorite sports team won every game. Unfortunately, that doesn't happen. As they say, life ain't perfect. And so we need to have a way of guiding ourselves as we think about how to both test our code and then fix it. So we're going to talk about testing methods, which are basically ways of trying code on examples to try and figure out if it's running correctly. And then once we've, in fact, isolated that there may be a problem, we're going to talk about debugging methods, which are ways of fixing the program that you know does not work as you intended it to. We're going to talk about both of those throughout this lecture. Now, let's start by thinking more abstractly about sort of when should we, in fact, do these tasks, right? When should you test and when should you debug? Part of the goal here is it would be really good if we could actually, ahead of time, figure out how to design our code to make it easier to do this. And indeed, all good programmers have that kind of practice. They break the code up into components that can be tested and debugged independently. They find natural breaking points between different parts of the computation, places where a computation is contained and then a simple result is passed on. And they write functions that capture each parse. That's going to allow us to more easily test pieces. Second thing good programmers will do is they'll write good documentation. When you've got a problem set, it's often easy to think, I'm just going to start working on this. But in fact, before you jump into code, think about writing down what it is you're trying to do. What are the expectations on my inputs? What are the expectations on my outputs? Even if the code doesn't strictly enforce constraints on the inputs by testing for them, this kind of documentation can be really valuable when you're trying to trace down why a piece of code is not behaving as expected. And finally, good programmers will document assumptions. I'm assuming certain conditions, both in terms of what's passed into the code and at certain stages throughout the code. And detailing those assumptions is going to make it easier for us to actually isolate where there may be problems. For example, because an input does not satisfy an assumption. All right, once we've designed our code, we can in fact start moving on to testing it. And to do the testing, basically we need to do two things. The first one is we've got to make sure our code actually runs. So we need to remove any syntax errors. We need to remove any static semantic errors. And fortunately, in most modern programming languages, including Python, these things will be handled automatically. Indeed, as you've probably already seen, if you write a piece of code that has either a syntax error, you forget a semicolon, or you've got the wrong kind of parentheses, or a static semantic error, when you try and load that into the Python environment, typically the interpreter, the evaluator, will complain. It will say you've got an error and not actually let you run. That makes it easy to fix those kinds of errors. Once you have those done, if you're ready to start doing testing, it's often really good to have ahead of time worked out a set of expected results. What do I expect the output of the program to be on a particular input? Because that's going to form a template for helping us figure out how to find where the bug actually lies. Okay, with that, we're now ready to start moving on to thinking about testing.